Cryptography is the science and art of encrypting data. Cryptography, as a field of science, includes the study of the tools that we use to communicate securely. Cryptography originates from the Greek words of cryptos and graphine, which roughly translated mean hidden writing. Cryptography has a basis on mathematics. More precisely, it's based on information theory and number theory. What is important to realize is that cryptography is everywhere around us. We use encrypted communications channels daily. For instance, HTTPS is the protocol that secures web browsing. Or take the wireless networking protocols that allow you to connect to the internet in the first place. Cryptographic applications can also be used offline. For example, take your encrypted files on a hard disk. Cryptography can also be used for other purposes like protecting media content on a hard drive or DVD or Blu-ray disc. In addition, we can also use cryptography to authenticate and identify users, and so on and so on. The most important use case for cryptography is secure communications. For web browsing, it basically means this. When your web browser loads a web page using the HTTPS protocol, only the server that actually hosts that content on the web knows what it is that you have been looking at. HTTP ensures that there is no eavesdropping and no tampering of the data that you just downloaded from this web server. HTTPS is based on another networking protocol called the Secure Sockets Layer, or SSL. Sometimes it's also called TLS, which stands for Transport Layer Security. This protocol serves two purposes. First, there is what is called a handshake. So what the protocol does is establish a secret key using what is called public key cryptography between your workstation and the server that is actually hosting the data that you want to view. We will come back to the terms secret key, public key, and what all of this means in a moment or two. The second phase of this protocol is what is called the record layer. So once we have established a secret key, we can start using that key to transmit and receive data. And this ensures confidentiality and integrity. Cryptography is often thought of only as the means for secure communication, but as said before, it can also be used to, for instance, protect files on a disk. This is because storing files is actually perfectly analogous to secure communication. When you save a file or a message on your hard disk and then you read it at some later time, what you're actually doing is sending yourself a message. So think of this as your past self sending a message to your future self. Next, let's review some basic terminology about encryption. So first of all, when talking about encryption, what we're really talking about is symmetric encryption. What this means is that when we are sending messages, encrypting and decrypting data, we always have two people. And in this example, the sender is called Alice and the receiver is called Bob. In symmetric encryption, Alice and Bob have agreed beforehand how to encrypt and decrypt their data. So for instance, Alice and Bob may have agreed on a certain password that they use to encrypt their secret messages or secret files. Encryption is always defined as a pair of two functions, E and D. In the picture, E and D are these black or blue boxes. E stands for encryption, which means how to encrypt data, how to make data not readable to someone who is an outsider. And D is the reverse operation, decryption. This encryption and decryption suite is also called a cipher. So a cipher is a fully functioning encryption and decryption package which always comes with both E and D. These E and D functions sometimes require some parameters. For instance, K here, which is the secret key. Now, in ordinary daily terms, a secret key could be, for instance, a password. And often the key also has some required bit of length, which is determined in bits or bytes. Finally, in these pictures or equations, you may see the letters M and C, which stand for plain text and ciphertext, or message and ciphertext, respectively. M is the plain text message that is fed into a encryption algorithm, and once the encryption is done and the original message is rendered unreadable to an outsider, it becomes what is called a ciphertext. And a decryption algorithm works in reverse. So you feed it with a ciphertext C, and what comes out is the plain text message. Well, if the recipient knew the passcode or secret key that was used to encrypt the message as well. What is fantastic about ciphers in particular is that the encryption algorithm is always publicly known. All of the secrecy comes from this secret key. This also means that you should never ever use a proprietary or a self-made cipher. These are usually not safe for any purpose. There are also some important distinctions when it comes to the use of these secret keys. You could have what is called a single-use key or a one-time key, which means that this particular key, be it a passphrase or a password, whatever, is only used once to encrypt one single message. A use case for this would be, for instance, encrypted email. When you send encrypted emails, you need to generate a new key for every email that you send. You could also have a multi-use key. There, this same key, also known as a many-time key, can be used to encrypt multiple messages. A common use case for this is encrypted files. So you can use the same key to encrypt many files at once. Multi-use keys require more processing power though. Finally, a few very important key takeaways. Cryptography on its own is a tremendous tool and it's the basis for many security mechanisms. But it's not a solution to all security problems. Cryptography is only reliable unless it's implemented and used properly, and it's not something that you should try yourself. Many examples exist of broken ad hoc designs. And finally, cryptography on its own is pretty useless if it's implemented badly or wrong.